Hello everyone and welcome to another supplementary video. My name is Kasanas. Guys, in this episode we're going to explore the particle system. Alright, let's get started. Okay guys, we're going to take a look at the basic particle system in Unity, and it's actually a fairly extensive topic, so I may have to break this up into a couple of different videos. We'll see as we're going forward. Let's start off right away by just kind of adding a particle system to our game. I'm going to go up to the game object option within the menu. I'm going to scroll down until I find effects, and you can see I have a number of different options within effects, and for now what we're interested in is the particle system effect. I'm just going to click on it and add a particle system to my game. It's right here. It comes in with the name particle system. I can see it over here in the inspector. Right away, we can see that we have a transform node. That transform node is used as it is for everything else. We can actually go through and move this object around. The other thing you'll notice right away is we have this additional little window that appears inside of our work area, inside of our scene. This allows me some basic control over the particle system. I can pause it, I can stop it, or I can restart it. This just really allows some basic control over the particle system in case you get annoyed by the particles going by. All right, let's go over in the inspector and take a look at some of the options within the particles system itself. We've got a bunch of options in here. You can see how long this is. We're not going to go over all of these. Each of these are drop-down menus, there's a ton of them here. Let's start off right away by going over the basic particle system. So right at the very top, right below the transform node, you'll see the particle system component. Below that lists particle systems. And this is all of our kind of initial settings of our particles right here, this top section here. Right now it's using a default particle, and we'll talk about how to change that default particle out afterwards. I'm just going to pause this for now because it can get really annoying watching it go by. Okay, so let's take a look at the basics of the particle system, and we'll just go over a couple of these really quickly. The duration is the period on which the cycle of the release of the particles is going. Right now, each of these is seconds, so that every 5 seconds, it's a kind of an end of a period for our particles. Looping means that it goes over and over again. I guess I have to restart this. Actually, let's just hit play and keep going here because I have to show you about this. If I change the duration, you're not going to see a whole lot happening. If I change this right now to 2, not a whole lot actually changes. But right now, it's actually looping at a faster pace. Not looping itself, like they're not being released quicker. It's just going through the cycle faster. If we remove looping, then the particles, if I restart this, will play one time for its duration for 2 seconds, and then it'll stop playing. So it is with this, if I change this now to 5, and I show you now, and I restart once again, you'll see it'll now go for 5 seconds, and then it will stop. So that's the end of the period as far as duration is concerned. If we leave looping on, it will just continue to go forever and ever, kind of ignoring that end point in the duration. Below that is pre-warm. So if I hit play right now, I'm going to hit play, and you will see that as my particles start, the particles start as the game starts, the particles actually start to emit. If I stop this and I turn on the pre-warm option, the particles will already exist within the world whenever I hit play. So let's just hit play. And you can see that, boom, the particles already exist. So something like this might be used if you maybe created a set of torches or something like that in your game, and you didn't want the torches to suddenly burst into life whenever your adventurer enters into the dungeon, right? You want the particles to already exist, the flame to already exist, the torches are already running whenever the adventurer first comes in. So you don't want them to suddenly come alive. So you'd use the pre-warm option to make sure that your particles already exist at a certain point in its operation. If you have pre-warm on, you won't have the option for a start delay. If you have the pre-warm turned off, you'll have the option for the start delay. And the start delay really just means don't start. If I put this at 2, for example, when I hit play, the particles won't start generating for 2 seconds. So 1, 2, generate particles. There we go. So that's all that does is it kind of waits for the particles to start generating before. It starts off as 0, so they'll kind of start right away. Below that is the start lifetime. This is how long the particles will live. All of these values right now are in seconds. So right now a particle will live for 5 seconds. You saw that when I hit play. If I just hit play again here, the particles go up off the screen. They live for a long time. If I change the particle's lifetime to instead of 5, I'd say change it to 1, you can see now the particles are dying off much earlier. Also, along the edges here, you will see, let me pause this. Along the edges here, you see a bunch of different options as far as drop downs are concerned. If we take a look at start lifetime, and we take a look at the options here, we have constant, curve, random between two constants, and random between two curves. This allows you to set up a range. So for, in this example, a range of their lifetimes. With nothing turned on, just with constant turned on, all of the particles live for the same amount of time. They all live for precisely 1 second. With a curve, I can draw a curve, and that's how long the particles will last, somewhere in between there. If I have random between two constants, I'll put in two different values, and the particles will last that long. And lastly, random between two curves, I can create two curves, and the particles will last that long. Let's take a look at the easiest one, just as an example here. We'll take a look at random between two constants. And you can see now I have two different values here, a 5 and a 1. So typically we want them to last anywhere between, let's say 0.25, so we can really see these things dying off quickly, and a maximum of 2, so they'll make it up a little distance. And you can see how it automatically changed right here on my screen as well. Now when I hit restart, you'll see that some of my particles are lasting longer than the others. Many of them are dying out right down here at the bottom. Some of them are lasting for 2 seconds and going all the way to the top. All right, awesome. We're going to find that there are a bunch of different things like this that have options, and each of those options might be slightly different depending on what choices you have. But anytime you have values, you'll have that same kind of choice. Okay, so below that we have our our start speed right here. Starts off as a value of 5. If I hit play right now, you can see that all of our particles have kind of the same velocity. They have exactly the same velocity, the velocity of 5. Again, we have the options to change this. So let's say I ran it between 2 points, and I put 0.25 here, and I put 25 over here. You can see that I got some particles shooting off with a high velocity and other ones that are kind of just moving extremely slowly. Below that is our 3D start size, and that's related to the start size itself. Start size itself allows us to change the starting size of the particles. And again, we have options that are allowing us to do random between 2. Let's make some of them tiny, 0.25, and other ones we'll make to 2, so they're a little bigger. And right now we can see, again, we're kind of getting that mixture. It's really kind of organic. That mixture is really nice. The 3D start size allows us to change it based on the values of the 3 axes if you have 3D start size turned on. Below that, 3D start rotation, same thing as a 3D start size with a checkbox. You can do it based on rotations. Otherwise, you can have a start rotation. If I just use the plain value, and let's say I say this is a 45, you can see that all of my particles have a 45-degree rotation when they start. And if I random between two constants, and let's make this -20 so we can see the difference, some of the rotations are between -20, and all of them are between -20 and 45. Below that is flip rotation, which is going to allow some of our particles to have the opposite rotation. That's all that does. The start color allows us to adjust the color of our particles, basically adds a tint to it. And again, you have a number of different options. Oh, yeah, right here, a number of different options. So you can see that we have different options, a gradient start, a random between two colors, a random between two gradients, or a random color. So you have a bunch of different options there if you want to go about and change some of those. We're going to take a look at how we change these over time a little bit later on anyway, though. Let's just shift this up a bit. So we can see some other ones here. Below our start color, we have gravity source, and the gravity source allows for either 3D or 2D. Remember, Unity has two different gravity or physics engines. The 3D and the 2D engines, they do not work together. So depending on what you want your system to be working on, 3D or 2D, you can have your physics be affecting the actual physics, the gravity being affecting the particles based on the settings you have in either the 2D or the 3D settings. Below that, simulation space. This is kind of a cool one. Actually, let's just change this gravity modifier first. I skipped that one. So again, the source is going to stay 3D. If I hit play right now and I turn on the gravity modifier to, let's say, 0.5, you can see that now gravity is having an effect directly on my particles. So the velocity is being overcome and the particles are being dragged down by gravity. So the force is being applied over time. I'm going to skip a few of these actually because some of them aren't really super important just for basic understanding of particles. But we will do simulation space because this is actually kind of a big one. Simulation space allows for either local, world, or custom. And the way local works, I'll just leave it on local for now, and I will drag this particle system around. So if I drag the particle system around, you can see that the actual particles remain connected, remain parented to, and connected with the actual emitter. Zero that out. With the emitter itself. If I go to world instead, boom, and I drag it around, now you'll see that my particles are being left behind. So the particles are generated, they are separate from the actual system I have here, and they are being left behind, which is really, really cool. If you were like, let's say you were designing something like a coal-driven train, and you had the stuff coming out of the top, the smoke coming out of the top, and the train was moving along, you wouldn't want the particle systems to be directly connected to the train itself, right? You'd want the particles as you generate the smoke particles from the stack, you want those smoke particles to be left behind as the train moves forward. So you'd work within world space at that time. Let me see what else is important here. Simulation speed, again, just increases or decreases the simulation speed at which the simulation of particles is running. Scale, oh, what did I skip here? Delta time, either scaled or unscaled. Scaled or unscaled basically allows you to set it up so that it's running based on the change in between frames, or unscaled allows you to not to ignore the frame rate. This is actually going to allow for things when something's paused or time is shut down for the particles to continue running. What do we have here? Play on awake. If play on awake is true, let me just stop this, or let me stop it like this. If play on awake is actually true, the particles immediately play. If play on awake is not true, you're going to see here that the particles themselves are not generated once we start up. So it's not generated at all. We can we can actually start the play with code so that the particles themselves will be generated when we want them to be. So we'll kind of turn them on or turn them off. Turn play on awake back on. Okay, below that is emitter velocity mode and what it's connected to. So by default, it goes to rigid body. This will add additional velocity to the particles based on movement of either the rigid body or the transform node. So if you want to be based on how the transform node's moving, you would set it up for transform. If you want to be based on rigid body, it would be based on the rigid body. Below that is an interesting one. Let's start this playing again, and it says the maximum particles. So right now, by default, it comes in with a maximum, and you guys can see that every time I've hovered over this, there's explanations. So if I am doing a poor job at explaining to you, you can actually hover over and get the information you need. Anyway, max particles is the maximum number of particles that it can be alive in the scene from this particle system at any given time. So by default, it comes in at 1,000. And if we change this 1,000 to a lower value, let's say 1, you can see that as long as there is one particle alive in the scene, no other particles can be generated. And you can see that some of them are dying off earlier. So as that particle dies, it'll generate a new particle. But we can only have one particle in the scene at any given time from this particle emitter. All right. And by default, it comes to 1,000. Uh, how many are actually coming out right now? There's not 1,000 coming out here right now, but we'll take a look at how we change that in just a second. Random seed just means how the particles are being generated. You can actually put in a seed if you want the particles to be kind of generated the same way all the time. You can take off this random seed right here, and you can actually put in your own seed value. And that will just mean that the particles are generated exactly the same way every time you start. With a random seed, they are assigned a random value, and these particles will come out in some random way. Anything else here that's important? Actually, I don't think so. Nothing else here is really super important right now. What is super important down below is the emitter. So the emissions themselves are right here. This is not actually the emitter. The shape is the emitter itself, but this is how many are coming out at any given time. So right now there are 10 coming out at any given time, 10 being generated at the same time, up to a maximum of 1,000. So these two values work together. I'll show you what that means in 1 second. And again, you have a bunch of different options here. You can change that based on time or based on how far away the particles are from the particle starting location. We can also set up so there's a burst. So let me show you what a burst is first of all. I'm going to just hit the plus sign right here. This plus sign is going to allow, there you go, you saw it, a burst of 30, one time, probability 100% over the cycle. So if we just watch this for a second, we're going to see the burst of particles that come out all at once, 30. I can change this value to, let's say, 300 and see a lot more particles bursting out. All right, so that's what a burst does. If I don't want to see this burst afterwards, I can get rid of it by hitting the minus sign, and it'll get rid of the burst, and I'm no longer seeing that burst now. Now, the rate over time will also change the number of particles coming out. If I change this rate over time to, let's say, 100, you can see I'm getting far more particles. And again, the far more particles are being held back by the maximum number of particles I can have in the scene at any given time. There are 100 being generated, every whatever, every tick. There's 100 being generated up to a maximum of 1,000. If I change this, so let's say instead I change this to a maximum particles of 10, watch what happens. I get a kind of a little burst and then those 10 and so on. If I change this value to, let's say, 1,000, oops, 1,000, 1,000, there my fingers are working nice, and I change this value down to 1, or maybe not 1, maybe 900. It's not what I want to show. I want to show the fact that they all come out in bursts, and I have to do that by, oops, maximum 900. I have to do that by changing the duration. Let's change this to 1. No, that's not what I want either. 2, no. I don't want that. I don't want any of this stuff. Leave it back at 5. What I'm trying to show here is that you can get bursts. So if the rate over time is preventing the number of particles from bursting, if I have like 100, let's see if I can get a burst to come out here. 10. I want it to be bursting. What is that? 90. It's not working the way I want it to work, which is a terrible example. But you can set these values up so that the maximum particles over time will come out based on the duration. So a mixture of these numbers here. Maybe I should have practiced this a little bit before I came in to show you guys. Based on the duration and the number of particles that are being generated at any given time, you can set it up so that you're getting a burst. What if I set it to 10? Is that going to work? That doesn't work. I tried 10 like 5 times, didn't I? So what you're trying to do is you're trying to generate a ton of particles, but have them only come out at a certain amount of over time. Uh, that's a bad example. Bad example. Anyway, guys, so you can get this kind of burst effect where they come spewing out over a specific amount of time. So unlike the burst effect that we had down here, if I turn on this burst effect and I put these back, so we're getting our maximum particles again, and I change the rate over time back to 10, we'll see our bursts happening here. Let's put it at 300. So unlike this burst, with the burst, all of the particles come out at exactly the same time. They come out at exactly time 0, 0, 0. So all at the start of the cycle, all 300 of those particles come out at exactly the same time. If you are able to adjust these values in such a way, along with the duration, if you can adjust those things in a very specific manner, you can get this kind of like flowing burst that comes through. I should have practiced. I apologize for not having practiced this particular thing before coming in to show you guys to get the exact values. But again, it's something you're gonna have to play with. That's true of anything I'm showing you right now. I'm really showing you this stuff very, very quickly. And what you're really gonna want to do is go through and play with all of these different values so you can you're gonna experiment and kind of get the look and feel you want out of your particle system. Okay, there's a couple more really important things I want to show you, and I think I'm going to cut off the video with the basic particle system, and then we'll go on to all this awesome stuff down here in the next video. Right below emission, so let's just close this up so we don't see it anymore. Right below emission is shape. And you'll note that both emission and shape were automatically turned on. None of these other systems besides renderer is turned on right now. Okay, so let's take a look at what shape means. Shape is the shape of the emitter itself. So by default, it comes in with this cone-like structure. And we can see the cone here. And I didn't mention this before, but as we increase the velocity of the particles, the cone itself got bigger. This is a representation of how fast the particles are going. If we actually go through and we change our start speed, move it down from 25, let's say we put it at 10 instead, you can see how my cone shrank down and became much smaller. Okay, so let's go down here and take a look at the options as far as the shape is concerned. By default, it comes in as a cone, but you have a bunch of different options, and each of these options are going to work vastly differently. You're able to change where the particles are emitted from, along like on the outside of the system itself, or from the base of the system, a bunch of different things that you're going to be able to go through and adjust. If we take a look at the cone itself, this is actually 3D. I'm going to put it in 3D mode for a second so we can actually see this 3D cone. And if I hit play, I'll just hit play right here. You can see that our particles are kind of like coming out well, let's increase it. I won't increase the size. You can see my particles are kind of coming out along the entirety of this cone. We can change the angle of the cone so we can make it bigger, wider, or smaller. So we can kind of make it into almost a cylinder. We can change the angle of it. We can change the radius of the cone itself. So based on how big the cone is, how much space it's going to create. The particles themselves, you can see now, are being generated by along the bottom of this cone. And as I increase the radius, the particles are spreading out. The radius thickness, we can actually change how much of the radius itself is actually generating. So now I'm not generating anything at all from the middle, just along the outside, just along this area right in here. And each of these options, these different cone, different shape options, will have different forms of what we're looking at here. So I'm not going to go through every single one with you. Let's just go back into 2D mode here for a second, and let's just choose a different one. Let's choose circle. So the circle itself comes in flat. If you want to see how the circle is actually working, all of these shapes, all of these emitters come in with a 90-degree rotation in the X. If you want them to go flat, you can actually change it like this. So you've got a 0 rotation. And you can see that right now the circle itself, actually it maintained some of the values that I put in there. It maintained the radius, it maintained the thickness, it maintained a couple of different things. So even though I went through and adjusted it for the cones, some of the information was brought over into the circle as well. And again, it works exactly the same way. So if I want to have it generate from just along the edge of the thing, I can set this to a radius thickness of 0. So right now it's generating all along the edge here. If I adjust it to a value of 1, it's going to be generating from the entirety of the base of this circle. All right. So this is going to kind of give you an effect where the circle effect is going to be, a burst in all directions, the same as kind of a sphere. A sphere will do the same thing. The circle is only bursting. If we take a look in 2D, it's only bursting along the one plane. If we change this to a sphere, however, we can see now we get a 3D burst that's occurring. So there's a bunch of different options down here in shape that you can change. I can't go through all of them because there are so many, but you're going to find the particle emitter that works best for your application. You're going to choose that particle emitter, and you're going to then set all of the different values to make sure that your particles are emitting the way you want them to emit. Let's just put it back to cone for now. Let's put that -90 so we can see it better in 3D. Let's put this -90 back in our rotation, and we'll get back out of 3D and go back into 2D. So here's our big fat cone. Let's go down here and just change it so we had our smaller angle. Oh no, we had a larger angle and we had a smaller radius. So that's what we had, something like this. All right, so that's our cone again. One last thing that I want to explore with you guys, if we scrub all the way down to the bottom, you'll note that renderer is also still on. So if I open up the renderer, we can see a bunch of different things inside of the renderer option. The render mode has a number of different options. We have the stretch billboard, horizontal billboard, vertical billboard, mesh, and none. Billboard just means that the objects are square, like you're seeing here, and they are always facing towards the viewer. So no matter which way I go in 3D space, or regardless of which place I go, my particles will always be facing me if I'm in billboard. Stretch billboard is very similar, except for the squares are stretched out. That's what it does. They're still facing the same way. Horizontal and vertical, we'll have them either facing one way or the other. So horizontal means now they're facing, if I go into 3D, they're now facing upwards. Vertical just means that they are facing again they were facing towards the camera at any given time. It's vertical movement. What else do we have in there? We have vertical. Oh, mesh. Mesh allows us to choose a 3D particle. So it's going to have a 3D particle. You can, if I turn on mesh, you can see now they're cubes. They look like cubes. But you can put anything you want in there as your mesh. You can change it so it's whatever you want. Let's just put it back to billboard for now, and we'll go back into 2D, and we'll come back in here so we can see it better once again. There's a number of other things in here. The normal direction, the normal is perpendicular to the face of the value. So it's just telling us what our normal direction is there. Material. Right now, we are using Unity's default sprite lit default material. We can change this if we want to so that we have different types of material. We'll explore material, I think, in the next video as opposed to this one here. What else is super important in here? There's a bunch of things that are going to be important here. All of these things here actually go through and affect how your particles are actually being generated. We have whether or not the shadows are working. We have whether or not what order and layer they are. So just like our sprites we talked about before, all of these things can go through and make changes to how the particles themselves are rendered. There's going to be other options up here that change it as well. So whether we have lights turned on and trails, etc., how going to change how these things are actually rendered. But down here is your actual renderer, and the renderer itself just determines the type of material that your particle has and actually how we're seeing the particles. All right, I'm just going to stop this for now. And that, I think, guys, is going to take us to the end of this particular video. I don't want this to get too long. What I'd like you to do, if you are one of my students, I'd like you to go in and play with all of the basic particles stuff that I just showed you. Take a look at how it works, see if you can get the particles working the way you'd like them to. And yeah, that's what I'd like you to do for now. In the next video, we're actually going to go through and explore all of these options. Well, not all, because again, there's a lot of them. We'll explore some of these options in here. We'll also explore the idea of the creation of a particle systems material. All right, everybody, I hope you enjoyed that. If you did, let me know down below with a thumbs up. If you didn't, a thumbs down is perfectly fine. I actually have had several weeks off. We just finished engagement week, so I didn't create any videos last week. And the week before that, I was on vacation, so I didn't create any then either. So I was a little bit rusty today. I do apologize. I should have planned better for part of it, and I didn't. Anyway, guys, I hope you enjoyed it. If you did, let me know down below. Thumbs up, thumbs down is perfectly fine. All right, thumbs up, thumbs down. Comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.